So as we move forward with data representation, we're now going to look at cumulative frequency diagrams. This, once again, should be something you're quite familiar with from GCSE, but we're going to look into the main features and exactly how they might be useful for us in A-level applied maths. To start off with, a cumulative frequency diagram is always going to be representing a grouped frequency table. The data we're working with here is the time that it took individual students to run 80 meters. The very first thing that we need from that group frequency table is to make sure that we have cumulative frequencies. So I've already done that on the table we're going to work with through this example. Second thing for you to check for is that you are using class boundaries. You are using the bounds. There is no gap in between the upper value in one interval and the lower value in the next. We have to make a continuity correction here to close any gaps. And then we can get down to constructing the diagram. We're going to plot some points which are going to be the upper boundary of each of these intervals alongside the cumulative frequency. So for the very first one, I'm actually going to plot the lower value with 0 because I know there are no data points below 9.6. The rest of the points we're going to plot the upper boundary of the interval with the cumulative frequency. So 9.7 will be plotted with 1, 9.9 will be plotted with 5, 10.05 is going to be plotted with 15, and 10.2 will be plotted with 32. Okay, from here we can just join those with straight line segments, and this is a completed cumulative frequency diagram. Now, the cumulative frequency diagram can be useful in different ways. Probably the first and the most popular thing you might be asked to do, or you might want to do, is to get an estimate of the median. Well, since the total frequency was 32, we know that we expect the median to be the halfway point, the 16th value. So if we read across from cumulative frequency 16, and we read down to the x values, to the time values, we get an estimate of Q2, an estimate of the median, 10.07 seconds. Similarly for the lower quartile, 1/4 of the way through the 32 pieces of data will be the 8th piece, which gives us an estimate of 9.95. And the upper quartile, 3/4 of the way, the 24th value, we get an estimate of 10.13. Okay, so that's the initial way in which we can make use of a cumulative frequency diagram. From here, we can do some of the things we might expect to do with quartiles. We can find the interquartile range. And we actually have similar values that we would use to create a box plot. So we can go ahead and make a box plot so we can see the spread of each of these different measures of location. So the lower quartile, the median, the upper quartile, that makes the internal box, the middle 50% spread between these values. The lowest possible value I might have is 9.6, and the maximum possible value I might have is 10.2. We don't have original data, so we don't know for sure that these are the minimum and maximum. But this will be our box plot, or an estimate of our box plot. We can still do calculations to decide whether or not there's any outliers. An outlier would be anything beyond 10.38. An outlier would be anything below 9.67. So actually, we might have an outlier in the data. Question could easily just ask, is there an outlier? And our response will be that there might be an outlier at the bottom end, whereas at the top end, we know that there isn't an outlier. Okay, what other kind of questions could we respond to? Estimate how many runners had a time less than 10.15. So we're interested in all of these times below 10.15, which takes us all the way up to a cumulative frequency value of 26. 26 runners had a time of 10.15, or they had a time that was faster they had a lower time than 10.15. So our estimate, 26 runners. Secondly, estimate how many runners had a time more than 9.95. Well, once again, I'm highlighting all of the times above 9.95, and I'll read up to the graph. A couple of things to be really careful on. The maximum possible value is 32, and the value that I got for 9.95 was 8. So I'm interested in the difference between 32 and 8. There were 8 runners who did not have a time more than 9.95. So 32, subtract those 8, leave us with 24 runners. Okay, similarly, estimate how many runners had a time in between 9.8 and 10. So I'm just going to highlight the right section, and I'm going to read off 2 values of cumulative frequency, 12 and 3. So 12 subtract 3 gives us 9 runners. 9 runners had a time in between 9.8 seconds and 10 seconds. Okay, and we're just about finished, but before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show. Exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A star.